Brendan said he would not uh, be here for the first part of class because he had an appointment this morning, but he was hoping to be back for the latter part. So I don't know if you probably can't see him when he's trying to come in, but if you do get any sense that he's trying to get in and I'm not recognizing him, let me know. All right, we are recording. Let me give you just a little bit of where I'm at right now, and it's not a really good place, but I think some of this happened. No, well, you probably don't know too much of any of this, so let me just fill you in, and it's being recorded so other will be able to hear it too. Two things are going on, and they're pretty big things. At the same time, I called my boss last night, Dr. Pruitt, and explained what was going on with me, and he was perfectly okay with it and just wished me the best on it. But two things are happening. Number one, I don't know which is one and which is two. I'll just give one first. A really good friend of mine, a member of our Sunday school class, she was 76 years old. She collapsed on Tuesday evening, actually in the church parking lot. She had been at a small group Bible study meeting and outside and masked and everything else, and someone was going to give her a ride home, and she just collapsed in the parking lot, was taken to the emergency room, and they stabilized her there. I was involved some of that because I'm her contact person, and she has no family in the state. She had a very much older sister who was at one time living in Virginia. We don't know her name. We don't know how old she is, but she has to be in her upper 80s because Judy was 76, and her next youngest sibling, was 10, 15 years older than her. So she never was close to any of her siblings. Like I said, the only one we know of at some point was this sister living in Virginia, and she has to be quite elderly. So I'm the contact person here, and so I'm having to deal with memorial services, with getting her apartment cleared out. She's in was in HUD housing, and they have a 14-day rule. You have to have everything cleared out in 14 days. But the place where she was staying, Episcopal Place, is really helpful, and really they're going to be doing great. But several members of the church wanted to, when they found out she was an artist, they didn't even know that. They wanted some of her artwork. So I've got to go sort of with a guy from church and kind of catalog all that. And we're also going to do some of her furnishing and stuff like that, trying to get it to people who need it, homeless people or people who have, fires have burned them out, or, having to start over, whatever. We're trying to coordinate all that stuff, and I've got a lot of help doing it. So that's going on. She actually died on Thursday, so we have until 1 week from this Thursday to get all of her stuff out. So that's going on with me. Nothing you can do about it, but it's distracting for sure. And then on top of that, I think I told y'all early on, I have a mild form of leukemia. The counts have skyrocketed. I mean, the white cells are way through the roof, 136, 140,000, when they're supposed to be no more than 11,000. So I've got to go in for a treatment. But they're going to make it a 2-day treatment because the counts are so high, 10% the first day and 90% the second day. They're trying to schedule that for this week, Thursday and Friday. So there goes Friday. Would have been the day I could take care of just about all this stuff with Judy, but now it looks like I'll be in a treatment all day on Friday. So it's really been a week. So I'm not worried about the treatment. I've had this same drug several times before. I handle it really well. They just give me Benadryl beforehand, and that knocks me out. I sleep through it all. And then, I come home, go back to bed, go to sleep, and the next day I do whatever I want to. So it's nothing harsh. I'm not worried about that part. But there goes my Thursday, which I'm going to miss class all day Thursday if this gets scheduled for this week. And then there goes Friday, the one sort of free day I have during the week when I could get to Episcopal Place when someone's there and they can let me in and stuff. So I'm having to work out trying to get over there, and I shouldn't even be going, but I've got to go because I'm the contact person. So I'll be going there Wednesday afternoon after my last class. So the only reason to tell you all this is my office hours are probably shot this week. Okay. I got a little bit of work done this morning, but most of the time was spent on the phone contacting people at Episcopal Place, at the UAB. The woman donated her body to science, so UAB has it, and they needed to send me information because I'm the contact person. And so I'm working with that to the donation of her body, and it's just it never ends, it seems like. So anyway, that's where most of my office hours this morning went. Unfortunately, it had nothing to do with school. That's why I called my Dr. Pruitt to let him know, and he was perfectly fine with it. So I feel like I'm cheating the school, but I've been spending a lot of time outside of hours, emails and grading papers and stuff like this. So he's not at all worried about it. But anyway, this afternoon, hopefully I'll have a more normal afternoon and maybe have 2 hours of office hours then from 4 to 6 when I normally do. Tuesday, I think my 1 to 3 will probably be still okay. So if you need to get in touch with me, that's going to be okay. Wednesday morning may be pretty much okay, 8 to 10. But in the afternoon, as soon as I get out of that class, I've got to meet a guy from church. He's going over and take picture of her artwork and furnitures and stuff like this so that we can get the information to people who might need some of it, want some of it, so they can, claim what they want. And then I'll be making arrangements for the rest of it to be taken somewhere. Okay. But Episcopal Place is really good about helping out with that. And then Thursday, I don't know yet because I haven't heard when they scheduled me for treatment, but it could be Thursday. It's completely shot. I'll have to miss every one of my classes because they want me to start at 7:30 in the morning. I said, if I'm only getting a 10% dosage, don't you think I'll be through by 3 in the afternoon so I can teach my late class? They said, don't bank on it. Okay, that they're going to do everything very slowly that day. It does sound like this drug is so effective. I've had it, like I said, several times before, and it does. It drives the counts down like crazy, the white cell counts. The bad news is my red cells, hemoglobin, hematocrits, and platelets are all really low right now too. So this drug sometimes hits some of them too. So this could make, I'm really anemic right now, and I'll be even more so probably after the treatment. But the other thing is, with the white counts being so high, that's probably what's got the other counts low, is that when this drug attacks, then it basically blows apart the cell. That's not quite right, but you could think of it that way. And so my body has to get rid of all that bad cell tissue, and it's in the bloodstream. So he's got a drug prescribed for me to start taking 2 days before the treatment and 5 days after the treatment. So I've got to find out, when the treatment's going to be and that type of stuff. So when it rains, it pours. So anyway, there's a good chance I will not be available at all on Thursday or Friday, and not on Wednesday afternoon either. So I have limited office hours this week. I'll try to make the best I can of them, and I'll be spending nights and things like this trying to get caught up as well. So anyway, that's my sad story. So things that are unavoidable, they're just going to happen. So Can you top that note? Do you have any issues, concerns, problems that you want to bring up now? Questions, anything? Okay, good deal. All right, so I guess we'll pick up and go since I'm sort of surprised no more people have shown up. Let me make sure that nobody's in the waiting room because I sure haven't seen them pop up. They're not. So it's just you and me this morning for now. Hopefully some more will be coming in later. So let me, there's one right now. Andy, if I can get him admitted. There he is. So we got the top of the alphabet and the bottom of the alphabet. It's just two in the middle, and Brandon, like I said, did let me know he has an appointment this morning. And let me make sure nobody else is trying to get in. Okay. So Andy, yeah, Andy has, yeah. Well, I'm in the same boat, so I was a little late myself. I think Jordan probably had been waiting for me, so I won't go into everything, but I'll just say this, summarize it. I've got two completely separate events going on this week that are going to eat up my time like crazy. Neither one of them have anything to do with the college, the school, or anything, but I will probably be out of pocket for my office hours on Wednesday afternoon 4 to 6 and possibly all day Thursday and Friday. I may be being scheduled for a treatment for my leukemia. They want to get me in some Thursday and Friday. They're trying to do a 2-day treatment, 10% one day and 90% the next day. And that's tentatively, well, I should find out this week which Thursday, Friday they're going to be able to get me in. So this week could be shot as far as office hours go, at least the latter part of the week from Wednesday on. This morning was pretty much shot because I was here in the office, but I was having to talk with people at Episcopal Place, a church member that deals with some of the homeless and other people like that. The people at the donation center at UAB, because she's donated her body to science, a friend of mine who died, and I'm the contact person. And I've talked with a few. I got some office work done, but not much. Most of it was tied up with other stuff. So anyway, that's going to be like that this week. So stand by to stand by. I did take advantage of the weekend printing off a good bunch of materials here that I'll be grading probably while I'm in treatment on Thursday and Friday, if I'm in treatment Thursday and Friday. So I'll get to redeem a little bit of that time, but not very much, because they give me Benadryl before they do the treatment, and about a half hour, 45 minutes after that, I'm gone. Benadryl knocks me out. So anyway, that's my sad story. So let's get going. Andy, did you have any questions, issues, concerns, or problems that you want to bring up before we get going?
No, sir. Only thing I need is to send you to my test.
Is do something about your test? I couldn't understand.
Yeah, I need to take a picture of it and send it to you.
Oh, okay, yeah, okay. And like I say, I'll try to take advantage of much of the office hours as I have available to get those kinds of things printed so I can be grading when I'm having treatments and things like that. But I'll be limited on time that I can do that as well. But yeah, if you get it to me, I'll try to get it printed. But like I said, I could be tied up with some of all of this stuff for most of this week. So if I don't get it done, sorry about that. But I'll get it done at some point. Okay. All right, so if there are no other questions or issues, let's go to the current slide here. And there we go. Let's do this. What we're doing, Chapter 8, Integration Techniques and Improper Integrals. We're going to focus more on the integration techniques, so we will do a little bit with improper integrals. And 8.1 is fitting integrands, or basic integration rules, basically basic integration rules. So we've had all these, or we're going to be covering some new techniques, okay? What we're doing now is trying to figure out how to handle things that we know so far. All right, what if this was our problem? The integral of 4 over x squared plus 9 dx. Any idea how we would approach this one? Okay. Andy, are you trying to say something, or is your microphone just popped on? Andy. Andy, your microphone is on. Were you trying to talk with me, or is it just background noise? Okay. Did you want your microphone on? Okay, good. Okay, thanks. Okay. So here we have the first integral, the integral of 4 over x squared plus 9. Okay. Now, right in that form, that doesn't look particularly conducive, but if you do look at, if you got your books open on page 516, number 19, right in the left column, the same page as this example, we see this form. We see the integral of du over a squared plus u squared. And they tell you what that integral is. One of your basic forms, that's 1 over a times the inverse tangent. They say arctangent, I like inverse tangent, of u over a plus c. Okay, so that's what we're going to use. Now right now it doesn't quite look right. Close but no cigars. Okay, the a here is obviously 3. Your variable u and x, we'll just interchange those pretty freely. But the variable here is the constant a, that is a constant. U is the variable because it's the du. The constant here is 9. That should represent your a squared. So a in this case is equal to 3. In this case right here. Okay. Now, your u squared and your x squared, they're perfectly, just interchange them. Okay. The du and dx then would be interchangeable, perfectly fine. That 4 is unnecessary here. So what we're going to do is take the 4 outside the integral, which is a perfectly legal thing to do, and then we'll have it in the form of dx over, and I'll flip it around, 3 squared plus x squared. And that looks just like this. So what is our integration? 4 on the outside, don't forget you took it out. Then you get 1 over a. Well, that 1 over a is 3 in this case, so it's 4/3. The inverse tangent of u over a. What is your u? That's your x. The u is the x, so it'd be x over 3 plus c. That's it. That's it. That's all there is to it. And you'll see in the book, that's what they got to. 4/3 arctangent. They use arctangent. I use inverse tangent. X over 3 plus c. Now, this looks pretty similar, doesn't it? But you do it completely differently. Okay? This one, because you have an x up here, and derivative of your denominator has an x in it, then you can do a u substitution. So this one will do let u equal, and of course here we'll do the most complicated part of the problem, and that would be your x squared plus 9. Now, yes?
I'll be right back. I don't know what's going on with my laptop. There's a black screen that's covering the lesson, so I'll just be right back.
Okay, I'll be watching for you, so I'll try to get you in. All right, back to us, I guess. Okay. Yeah, it's just you and me now. Then, after the let, there's a then. Du. Now, this u has nothing to do with the u's up here. That was a different problem completely. Don't confuse these. Okay. The du here would then be, if u is equal to x squared plus 9, du would be what? Perfect. Okay. Now, what we have here is a 4x dx. We don't want that. We want just a 2x dx. So we just pull the 2 of those on the outside. So this is going to be 2 times the integral of 2x dx, which is du, pretty ugly u, over u, right? Because your u was x squared plus 9. And I think we know what that is, don't we? Antiderivative of du over u? Log of the absolute value of u. Okay? Well, what is u? X squared plus 9. So that would be 2 times the log. Now, notice here, I'm going to lose the absolute value sign. Why? No matter what value x is, positive, negative, fraction, decimal, rational, irrational, x squared is not going to be negative. You add 9 to it, and that's still not negative. Okay? Plus c. And if you wanted to, just from the rules of logarithm, you could call that the log of x squared plus 9 squared plus c. You didn't have to do that last step. This step was perfectly fine. Let's see how the book left it. They left it in this form right here. Okay? That integral was a log of x squared plus 9 plus c. Any questions on either one of those? Any? Okay. Now, how about this next one? Okay. Now, I probably should have been saying this all. Oh, here's someone coming back in. I don't know if this is. Yeah, I think this is Andy. Let's see if I can get him back in. Let me make sure that's Andy, because it blocks out my ability to see. Yeah, Andy's back in. Okay. Andy, is your laptop doing any better? Well, he may not be able to hear me yet, but hopefully he'll be in soon. Okay, is your laptop better?
Yes, sir.
Good.
Black screen is covering the whole section.
Yeah.
Slides, so I had to
Yeah.
restart.
Okay. That has happened to me. It's happened just about everybody, it seems like. I think our wireless infrastructure is just stretched to the max right now. It just can't handle it. Okay, now something I probably should have pointed out at the very first example. All three of these are rational expressions. That's a rational expression, that's a rational expression, this is a rational expression. These two up here are what we call proper rational expressions, meaning the degree of the numerator is less than the degree of the denominator. This has degree 0, that has degree 2. This one has degree 1, that has degree 2. So we proceeded okay on those. This, however, is what we call an improper rational expression. Excuse me. The degree of the numerator is equal to the degree of the denominator, both 2's. What do we do on one like this? You start off by long division. So divide your denominator. And what I think I'll do, are y'all okay with me erasing what I've written up here, or do y'all need it a little longer? Let me know something. You okay with me erasing? Okay. Okay, somewhere down here I should be able to have, I can't see my There we go. It was being hidden. Okay, I'm going to erase all the ink on my screen. Okay, the reason is I've got to do a long division with this. So let's do x squared plus 9 into, it's always denominator into the numerator, 4x squared. And probably I should put a plus 0x here and plus 0x plus 0 here, but I think we're going to be okay. So let's start. X squared will go into 4x squared 4 times, right? 4 times x squared is 4x squared. Remember, that's how we do long division. And then 4 times 9 is plus 36. Okay? Now we subtract. Okay? Of course, let me go on and put the 0 up here so it makes sense. Now, you can subtract if you're okay doing that, or what is subtraction but changing signs and adding, just like for the sign numbers. Make this a minus and make this a minus. Okay? And then we proceed to add. Okay? Add this, that goes to 0. Add this, you get minus 36 as a remainder. 36 is a lower degree than your divisor, so therefore you could write this as minus 36 over x squared plus 9. Hey, we have done this, okay? So this integral here, when you do that long division, would be the integral of 4 dx minus the integral of 36 over x squared plus 9 dx. We just split that into two integrals here. Okay. Now I think you can do this one, right? What would that be? That would be 4x, right? Minus. Now this one is just like that one. So if I had been looking ahead a little bit further, I would have left that first one up there. But remember how we did that? From number 19 across in the left margin here. I'll write it down again for you. The integral of du over a squared plus u squared is equal to 1 over a times the inverse tangent of u over a plus c. Okay? Now what do we say here? Our u is equal to x. So we're just going, everywhere we have a u up here, we're going to do a u, x down here. Here, our a is going to be, now, yeah, that same 3 that we had before. Okay? So everywhere we see an a here, we're going to put a 3 in our answer here. So this would be 4x minus, oh, we're going to take this 36 outside. Okay? So that would be minus 36 over a, which is 3. So that's going to be a minus 12 times the inverse tangent of x over 3 plus c. So there's our answer to that one. Now I forgot to check. Yeah, I checked before and did it. So what do we have? 4x minus 12 times the inverse tangent, they call it the arctangent, of x over 3 plus c. That's how we do it. So, rational expressions, make sure they're proper rational expression, meaning the degree of the numerator is less than the degree of the denominator. If it's not, if they're equal or the degree of the numerator is greater, do your long division first. Then deal with what you have. This gave us the integral of 4 dx. That was pretty easy to do. And then we had a form a lot like this one here. Okay. I hate to do this early, but this has been such a an incredibly trying time. Let me get a little bit of, okay, I'm going to blame it on what I can get away with blaming it on. Like I said before, they found out when they did my blood work I'm extremely anemic now, so I just run out of energy very quickly. So I'm depending on Coke to boost my energy a little bit. It's temporary, but hopefully it'll last long enough. So hold on just a second. Sorry about this. I hate doing something like this in class, but I'm losing it. I hate interrupting class like that, but situations as they are, can't help it. Sorry. Let's watch how they solve these. I think that's pretty similar to what we did. So let me erase all my ink so we can see what they, oh, well, I didn't need to. Using the arctangent rule, number 19 on the column there, let u equal x, a equal 3, just like we did. And then the integral of 4 over x squared plus 9 dx is 4 times the integral of 1 over x squared plus 3 squared dx. That's just the constant multiple rule, just pulling the 4 to the outside. Now you got a form just like number 19, and that answer is 4 times 1 over 3, 1 over your a, times the inverse tangent of x over a, that was u over a in the margin thing, x over a here, because x was u and a was 3, x over 3 plus c. That's it. Now, a little bit later in this chapter, we will come up with a way to solve this without having to remember or look up the arctangent rule. But right now, it's one of our tools. Use it as you can. We'll find a way to avoid that in the future. I hate memorizing things. I do recognize this would be an arctangent form, but I do check the table to make sure I've got my constants in the right places. Later we'll show how to do it without avoiding the ambiguity altogether. Okay, so that was the A part. And they just wrote that as 4/3 arctangent x over 3 plus c. All right, that's what we got to, by the way. The arctangent rule does not apply to the B part. This is going to the B part. I don't know if you can see that because this thing's blocking it. Because the numerator contains a factor of x. So consider, okay, they say the log rule, but guess what? Do your u substitution, then do the log rule. And this is exactly what we did. Let u equal x squared plus 9, du is equal to 2x dx. Put that in here. Since we only want a 2x dx here, we bring 1, 2 on the outside, and then the other is 2x dx. This is your x squared plus 9. What you have now is 2 times the integral of du over u. And that is your log rule. Integral 2 times the integral of du over u. And that would be log u plus c. Okay? Now go back and plug in what u is, or u are. Okay? And that would be x squared plus 9. And in plugging that in, you see that can never be negative, so you get to lose the absolute value bars. So that becomes 2 times the log of parentheses x squared plus 9 plus c. That's it. There's your answer. Like I said, you could use the log rule and move this 2 to be the exponent of that. That would be the log of x squared plus 9 squared. It's not necessary, and they don't do it. Perfectly fine to do it if you want to. Okay? The C part. Now the degree of the numerator is equal to the degree of the denominator, making this an improper rational expression. So you should first use division to rewrite the improper rational expression as the sum of a polynomial, in this case just 4, plus a proper rational function. So we do that, and they didn't show you how they did it. They just said, plop, there it is. So 4 plus this. We'll split that into two integrals. The integral of 4 dx minus the integral of 36 over x squared plus 9 dx. And that's what they do here. Okay, now they pull the whole 36 out of here. That was a little premature because we're now, no, it's perfectly fine. It's correct, in fact, because now you're left with the arctangent rule again. And this will be, the a is still 3, and the u is still x. So that would be minus 36 times 1 over 3 arctangent of x over 3 plus c. This 3 will go into 36 12 times, so it's 4 minus 12 times the arctangent of x over 3 plus c. And there's your answer there. Any questions on example 1? One of the 3 parts of that? Okay. Now, here, they're skipping example 2, 3, 4, 5, and 6. Okay, so I guess we'll be doing those on the whiteboard. So let me just make sure nobody else is waiting. No, they're not. So let's get to the whiteboard. And let me delete that. And I've got a little more housekeeping to do, moving this taskbar out of the white space and moving the white space away from everything else. Okay, that looks good to me. All right, let's hit example 2. I think I'll have to get the book in my lap to deal with this. Get the pad on top of the book and see what I can read. This is a definite integral. Okay, we're going to be doing the integral from 0 to 1 of x plus 3 divided by the square root of 4 minus x squared. Okay, dx. Boy, they start off with a doozy, don't they? The ones they showed on the slide set, pretty straightforward. This one, a little bit more involved. Okay, and of course this one they don't have on the slide set. Okay, so let's see what we're going to do here. All right, now first thing I'll look at is the fact that we've got, this is the most complicated part. The square root, it's in the denominator, and you got something inside that. So I'm looking at 4 minus x squared as being a potential u here. Okay, and the du would then be minus 2x. Well, I can deal with the x part, but this plus 3 I can't deal with. So what I suggest to you, split this into 2 integrals. Okay, the first one will be the integral from 0 to 1 of x over the square root of 4 minus x squared dx. And the second one would be plus 3 times the integral of 0 to 1 of just dx over the square root of 4 minus x squared. All right, this one is relatively straightforward. Just your u substitution like we started with. Let u equal the innermost part of the most complicated part of the problem. Most complicated part is this radical in the denominator. What's the innermost part of that? 4 minus x squared. Then, always follow your lets by then, du is equal to minus 2x dx. Well, we have an x dx up here, So let's divide this by minus 2. Okay, that gets rid of this. Now we got the x dx we have here, and we have a d minus du over 2 here. So let's pull out the minus 1/2, be negative 1/2. That's what we got from here. The integral from, okay, we need to change our limits. When x is equal to 0, your u is equal to 4, right? X equals 0, u equal 4. When x is equal to 1, I'm sorry, no, here, yeah, I was looking at the wrong place. This would be 4 minus 1, that would be 3. Now, I don't like the looks of that at all, because you got the bigger number over the smaller number. We need to go from lower to higher. So we'll come back and do that in a minute. Let's go on with what we have here. We got the minus 1/2 out front. The du is going to be your x dx, and that's what we got here. So it's x, this is just the du here, is your x dx here. That's the du. Over u to, I don't like doing the radical, this is u to the 1/2. Now, I don't like having it in the denominator either, so I'm going to take this one more step. I'm going to do two things at once here. I'm going to flip the 3 and the 4, which of course negates the integral, which does away with your minus sign. So that's going to be a 1/2 the integral from from 3 to 4. I probably should erase that because that's pretty ugly. Three to 4, and that's not very well placed 4 either, of u to the minus 1/2 du. Okay, now that's simply a power rule. Okay, and what would that be? Antiderivative of this would be u, don't forget the 1/2 out front, u to the, add 1 to this, remember antiderivative you add 1 to this, you get 1/2 divided by 1/2 the new exponent, which is multiplying by 2, and I'm going to multiply by 2 out here, and that goes away. And that's evaluated from from 3 to 4. Okay, again, probably need to erase that scratch that I have there. Okay. All right. So what would that be? Well, the square root of 4 is 2 minus the square root of 3. All right. Oh, here comes Ashton. Very good. Okay, let's get Ashton in here. And hold on a moment while I mark him on the roll. If I can find my pen. There it is. So Ashton's here. If I can untangle all my wires here. All right. Now we knew that Brandon has an appointment this morning, so he said if he can get back from the appointment on time, he'll join the class later. If not, he'll pick it up on YouTube videos. So that's what we got so far. Ashton, we're on in Chapter 8, Integration Techniques and Improper Integrals. We're going to focus on integration techniques right now. In 8.1, Basic Integration Rules, and we're on page 517, Example 2, top of the page, not on the PowerPoint, so we're doing it on the whiteboard. And we've got the first part of it done. Here was our problem, fairly complicated looking integral here. What we did, we split this into two integrals, integral of x over this part here, plus 3 times the integral of dx over that part there. The first part here, we did a u substitution and finally got our answer down here. Okay, and this is a definite integral, so we don't have a plus c. Okay, let me make sure. Okay, they're doing this slightly differently than I am. I think our answer is going to come out okay. So we'll see. We'll wait and see. On this part here, this, if you go to the previous page, page 516, and last time we were looking at 19, which is inverse tangent. Now we're looking at 18, which is an inverse sine. So looking at 18, I'm going to write down what 18 is. I don't have a lot of room, so I'm going to do it over here from here, but I'm afraid we're going to need all this space. So number 18 says the integral of your du over the square root of a squared minus u squared du. And they tell you that would be the inverse sine. They do arc sine, I do inverse sine, same difference, of u over a. Now remember the one we were doing before, when you did the inverse tangent, you had a 1 over a out front. The inverse sine, you do not have that, okay? Plus c. But we got a definite integral, so I'll leave off the plus c for now. It really should be there, but we've got definite integral, okay? So let's compare these two. What the u is here, if I could get the pen to show up, here, your x is here. See, in every sense, the u and x. So u is equal to x. And what we have is the a here. This would be 4 is a squared, so a would be 2. So your a here would be 2. All right. With that in mind, this part here becomes 3 times, okay, inverse sine of u over x over a, x over 2, okay, evaluated from 0 to 1. Okay, so let's do this one. That would be 3 times the inverse sine of 1/2 minus the inverse sine of 0. Well, 0 over 2 is still 0. All right, now we have to go back to our trig inverse functions. This is equivalent to saying, if this is equal to some angle, okay. For your trig functions, you take the trig function of an angle. It gives you a number. The inverse trig functions do the inverse trig function of a number to give you an angle. So I'm going to say this thing right here has to give you some angle. I want to call it theta. That reminds me it is an angle. Okay? And I'll think in radian modes too. So this will be 3 times, and this is now equivalent to, I should put it like this, equivalent to the sine of theta is equal to 1/2. That's what inverse functions do. They flip the input and the output. Okay? What angle theta has a sine of 1/2? That would be, I don't hear too much talking out there, that would be this, I'm sorry, that would be the angle pi 6th. Okay? Minus what angle, and you do the same thing here, set this equal to, I've got to close my door in a moment. Hold on, my wife just got home. Close it. Thank you. Okay. Set that equal to theta And that's equivalent to saying the sine of theta is equal to 0. What angle would that be? Well, for sine, that would be 0. So this gives you a 0 here, minus 0, which we can just ignore. So this part just gives you pi halves. So we got a plus, this is so aggravating, plus pi halves. Alright, that's what we got for that integral. Let's see what they got. They put the minus root 3 in front, which makes no sense at all. Then a plus pi halves, which makes sense. Minus a minus 2, which is plus 2. Now they went about it a completely different way. If you like their way better, go for it. By all means, don't let me hold you back. Okay? But same answer. Let's plug in our calculator and see what we get. I'm using my telephone. Okay, I got to turn it sideways because I'm going to need the scientific calculator. 2 minus square root of 3. On my phone, I have to do the 3 first and then the square root symbol over here. Plus, I'll do the pi symbol. If it'll come on, there it goes. Divided by 2 equal. And I get something about 1.8387 blah 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 blah. I would say 1.8 at best. The book carries a few more digits and it says 1.839, which is exactly what mine would round to if we went 4 decimals. I don't see how they have justification for 4 decimal places, but they think they do, so let them go for it. Okay. I'm at 100% of that, so I'm going to set my calculator up there out of the way. Any questions on that problem? Any whatsoever? Okay, now I've got too many things stacked together. Alright, they have a little blurb here on technology. The midpoint rule can be used to give a good approximation of the value of an integral in example 2. For n equal 5, that approximation is 1.837. I'm not about to go back and do the midpoint rule here. However, if you want to, you certainly can look at that. When using numerical integration, however, you should be aware that the midpoint rule does not always give good approximations when one or both of the limits of integration are near a vertical asymptote. In this case, we weren't. Our vertical asymptote here would be x equal 2, plus or minus 2. You'd be in big problem if you try to put a 2 in here, okay? Because that would give you a 4 minus 4 would be 0, or minus 2 in here would still give you 4 minus 4 equals 0. So you couldn't be close to plus or minus 2. The illustration in the book, which I wish they had shown on the slide set, is that, and you can see over there at minus 2, I don't know if you can read it, it's starting to bend up, so that would not be a good thing. And the plus 2 is gradually going up there, but 0 to 1, you still got a long distance from either one of those vertical asymptotes, so it gives a pretty reasonable approximation. Okay, why did they go into all that? I don't know. Okay, but anyway, then they do the next one. They say, what if you had the integral from 0 to 1.99, which is awfully close to 2, which is your vertical asymptote of the same integrand. Well, your integrand, doing it analytically like we just did, would have given you 6.213 if you'd done the midpoint rule with n equal 5 then, rather than being within 2/1000ths of the answer. You're barely better than 1 away from your answer, okay, 0.6 or so, okay. So rather than doing 0.002, you're 0.6, so not nearly as good of an approximation. Why they brought that up, don't know. Not going to mess with it. Okay? Now, rules 18, 19, and 20, those are your inverse trig functions. The basic integration rules on the previous page, preceding page. Sorry, I'm going to have to take a little more caffeine here. Sorry. It's not that I'm necessarily sleepy. I had one of the best night's sleep last night that I've had in a week or so, but I just have no energy. The anemia, I think, is getting to me. So, rules 18, 19, and 20 of the basic integration rules on preceding page all have expressions that involve this one, a squared minus u squared. That's a dead giveaway for a sign substitution. The previous one had a squared plus u squared, dead giveaway for a tangent. Oh wait, I'm saying what we're going to do in the future. This would be inverse sine, that would be an inverse tangent, and the one that would be u squared minus a squared, that's a dead giveaway for an inverse secant. Okay, which, by the way, I avoid inverse secants as much as possible, but sometimes you have to deal with them. Okay. Now, they're mentioning that now because of example 3. So let's move on. Anyone need me to leave this up a little bit longer? If not, let's clear those drawings and do example 3. Okay. Here's your integral. Example 3. Find the integral of x squared over the square root of 16 minus x to the 6. What? And then you have a dx. That's a 2 up there, a 6 down here. Okay. Now, we haven't messed much with x to the 6th, and if you looked at this from a u substitution view, that would give you the derivative of that thing inside the denominator, the innermost part of the most complicated part of the problem. The derivative of that would be a minus 2x to the 5th. That's nowhere close to an x squared. Okay, no way you can get it there. So u substitution, not the best bet here. Okay, well, not that u substitution anyway. Here is the u substitution I would use. And this isn't exactly the same context as a u substitution before, but let's let u equal I want to say x cubed, and I think that's what they do. Yeah, let u equal x cubed. We're going to go innermost part, not the 16 minus 6x cubed x squared. We're going to go here. Now, why would we do that? Well, look at your then. Du is equal to 3x squared dx. That gives what you have as your du here, except for the 3, so we can divide out the 3. Okay, now this is an indefinite integral, so this is going to be 1/3 times the integral of du, that's your, when you divide this out, your x squared dx, 1/3 on the outside, of the square root of 16 minus, now if u is equal to x cubed, then another then down here, u squared would equal x to the 6th. If you squared this and squared that, that's what you get. So this would then be, this x to the 6th would be a u squared. All right, now we've got it looking like number 18, wasn't it? Yeah. Okay. And number 18 was the integral, and this even has the du's in it, du over the square root of a squared minus u squared. Okay, so all we got here, u is u, here and here and here and here. The a is equal to 4, because a squared, 4 squared would be 16. So what is this? That example or integration rule 18 was, that came out to be the inverse sine of u over a. This is the inverse sine. They like arc sine, I like inverse sine of u over a plus c. So what we have now is 1/3, and this goes directly here, only a is 1/4 of inverse sine of, and your u here is your x cubed here. So it's a minus, ooh, I can't even read what, oh, that's inverse sine of x cubed, that's what u is, over a was 4 plus c, because this is an indefinite integral. All right. Oh, goodness gracious. I'm so out of energy. So, and I keep blaming the anemia, but you know what? Emotionally, this has been a very stressful week, so it's probably a little more than the just the anemia. So that's what we got, 1/3 inverse sine of x cubed over 4 plus c. Good deal. Now, in your little side note here, and I don't think we have time to go through this, but it may be something similar. From part of example 2 above, we had, if I can find it here, right here, we had something that looked like that. The integral of 3 over the square root of 1 minus x squared. Okay, that is very definitely a sine, inverse sine function. If you have the 3x upstairs, then you do a u substitution and you use the power rule on that one. And if you had x squared upstairs, okay, it says which, if any, of the integrals listed below can be found in the basic integration rules. A and B can be. For any that can be found, do so. For any that cannot, explain why not. Well, in that case, you have, if your u was the square root of 1 minus, I'm sorry, u was 1 minus x squared, then the du would be nowhere close to 3x squared. Okay, you can't have it there. So that's the one that you can't. That's all they wanted to do there, so you can look at that if you'd like. Now, two of the most commonly overlooked integration rules are log rule and power rule. I don't know why they say that. We use them all the time. Notice in the next two examples how these two integration rules can be disguised. Okay, now he's making all sorts of subterfuge here. It really isn't that bizarre. Okay, anyone need me to leave this up a little longer, or can I go on and erase? Erase? Okay, I heard no objection, so I'm going to erase. Okay, I'll tell you. I'm going to try just some water this time. I don't like drinking that much sugar, but the caffeine and the sugar I think I need. All right, here's example 4. Here's your integral. The integral of, again, an indefinite integral, 1 over 1 plus e to the x dx. Okay, now, a pretty innocuous looking little problem, but once you start dealing with it, you think, hey, how in the world are we going to go about solving that? Okay, a u substitution, certainly the most complicated part would be the denominator, and in a sense the innermost part of that denominator is e to the x, but the derivative of e to the x is e to the x. You don't have that in the numerator. Okay, neither do you have a 1 plus e to the, or if you let u be 1 plus e to the x, the du would still be e to the x, and you don't have that in the numerator. So that's becoming a little more obscure. Okay, but what if you, well, all right, this certainly is what they call a disguised problem. And so they introduce a trick here. And here's the trick. What we're going to do on that numerator, the denominator we can't do much with, so here's what we do. We start with the 1 that was already there. Okay, my phone's ringing. And this is someone from Bessemer. Just in case it's one of the students, let me get it. Good morning, Charles Fowler speaking. Andy, when he came in. This last week or so has been one of the stranger weeks in my life. Okay, I've got 2 things going on right now. A very good friend of mine died last week. She collapsed. She was a member of our Sunday school class, and she had a mental illness somewhere on the spectrum between bipolar and schizophrenic, but she was just a beautiful individual. She was 76 years old, and she collapsed in our church's parking lot after attending a small group Bible study there. And a woman was with her at the time. She called 911, and they took her to UAB emergency room, and basically from there on, that was last Tuesday, Thursday, she died. I'm her contact person because she had no family in the state, no family anywhere close, and she wasn't close to any of the family that may still be alive. We don't even know if her older sister, who was quite a bit older than her, who would make her in her upper 80s now, if she's still alive. She lives in Virginia, or she lived in Virginia at one time. They didn't have any relationship at all as long as I've known Judy, which has been probably 20 or more years. She never hardly even mentioned her sister. They didn't have any communication at all. They were far enough apart in age, and Judy's mental illness, they just never, it was sort of like the sister didn't want any part of her. And so I'm her contact person, and that was the chaplain at the Episcopal place where Judy lived, wanting to talk about a memorial service, but she's having to deal with the funeral where she is, so so it wasn't a good time. So anyway, that's what's going on now. And on top of that, my white cell counts are through the roof, and I'm going to have to get a treatment either this week, next week, or sometime as soon as possible. And that's probably going to be Thursday and Friday, either of this week or next week, or as soon as possible. They're trying to get it done for this week. So I'm trying to take care of Judy's affairs. HUD, she was in HUD assisted living, the facility where she was, Episcopal place. HUD requires them to have the apartment cleared out in 14 days. And I'm the only contact person, no family, and so I'm dealing with all sorts of things, the memorial services and that kind of stuff. So it's kind of crazy, and especially on a week I'm going to have a treatment. So um, that's what the interruption was. I apologize for that, and I've lost my pen. I don't know where my ionizing pen went. Usually I set it right there. It's not there. Okay. This is sort of normal for weird times like this, for weird things to happen. And I have no idea where the pen went. Oh, here's Brandon. I will get him in. Perfect attendance today, folks. Way to go. Brandon, glad you could make it back in time. Now let's see how the time is going. We have until 11:40, so yeah, you got some time. Brandon, things are just falling apart here. I just had a phone call, and I had to set down my ionizing. Oh, and it fell to the floor. That's where it went, which is not good because that's a very expensive pen. Okay, sorry about that. So Brandon, it's a mess. Okay, and we'll just deal with it like that. I'm just give you a quickie. Two things are going on with me this week, have nothing to do with the school except how it impacts the school. Number one, a very good friend of mine died last week, and I'm the contact person. She has no family in the area, no close family at all, period. And she had a sister living in Virginia, but the sister was way older than her. She died at 76, so the sister would have to be in her upper 80s, and if she's still alive. So I'm having to deal with everything with that, which is fine. That's Judy deserves it, but I've never been here before, and I'm having to deal with memorial services at our church and at the place where she stayed, Episcopal place. That's what the chaplain was just calling me from there. Dealing with her effects and dealing with all the things there. It's been crazy. And on top of that, my leukemia counts are through the roof, and they want me to have treatment, preferably this week if they can schedule it. So it has been totally crazy. So anyway, that said, let's get back to calculus. Here is the trick that they're going to do here. Here is our first, the problem. I'm going to put the dx way out here, and you'll see why in a minute. I'll extend this line some. Here's the trick. We're going to add 0 to this. Whoa, that doesn't make any sense, but we're going to pick how we're going to add 0. We're going to add e to the x and subtract e to the x. That's why they say this is disguised, okay? Now we'll split that one into two integrals. The first integral will be 1 plus e to the x over 1 plus e to the x dx minus the integral of e to the x over 1 plus e to the x dx. Oh, what a nifty little trick we had. Okay? They had, actually. This one, of course, is 1. So this is just simply the integral of dx, which I think we can all do. Minus, now this one we can do that u substitution we were testing before. Let u equal, and let's do the whole denominator down there, 1 plus e to the x. Then, just like we said before but didn't actually do it, du is equal to, derivative of 1 is 0, derivative of e to the x is e to the x dx. And that's precisely what we've got in our numerator here. So this is minus the integral of du over u. There it is. Well, this, you know, is simply x. This is simply minus log u. And then we'd have a plus c here. Well, let's go back and plug in what u is, or u are, x minus the log of, and what was our u? 1 plus e to the x plus c. No definite integral here, so we just, that's it. That's our answer. Now, time out a moment here. If you're thinking, hey, that looks like a log of an e here, is there some way we can combine that? No, there's not. The log rules pertain to products, quotients, and powers. They do not apply to sums and differences. The 1 plus e to the x, there is no simplification for that log. Don't even try it, okay? If that was times, no sweat. The log of a product is the sum of the logs. If that was an exponent, the log of an entity raised to a power is that power times the log of that entity. Those are your log rules. There is no log rule for a sum or a difference, so don't even try it. So that should be our answer to example 4. X minus log of 1 plus e to the x plus c. Any questions? All right. Now we move to example 5. Okay. Brandon, you okay? You caught up enough that do you need any of this explained any further? Okay. Okay. All right. Good deal. And that will be posted sometime this evening, I hope. But these have been such crazy times. I don't know how my evening's going to turn out, but I'll try to get it done then. All right. So I'm going to clear the drawings there and go to example 5. Okay. We got time. Oh boy. Here's an integral of a cotangent x. Oh, this is starting good, isn't it? They put that in parentheses. I'm not entirely sure why. Times the, and they put this in a bracket, the log. Oh, I can't. I always tend to do that, and I don't know why. Okay. I guess I combine my L with my N, especially with this pen. The log of sine x. dx. Now that looks like an integral you'd be doing every other day, wouldn't it? All right. Here's what I suggest. I suggest we write this cotangent in terms of sines and cosines. So let's try that first. The integral of cotangent is cosine of x over sine of x times the log of sine of x. Trying to think if there's anything we can do to make that any better. I can't think of it now. So let's just do log of sine x. Okay. Now, dx. That's all legal, right? Now to ask the question, what's the innermost part, the most complicated part of that problem? Well, this has a denominator, this has a log, but look at that, it's the same thing there. Let's see if that's going to work. Let's let u equal sine of x. My pen is not writing well. Sine of x, then du is, guess what, folks? Derivative of sine is cosine. X dx. And looky there. Here's your cosine x, and there's your dx. So let's see what that gives us in terms of u now. This would be the integral of log u, because u was sine x, over u du, because cosine x dx is du. Well, are you in for another substitution? Let's just want to let it be v equal u, let's see, I'd say log u, because that's more complicated than that, even though it is in the denominator. Then dv is equal to 1 over u du. Look at that. So what do we have now? We have the integral of v, this is v, log u, and 1 over u du is dv. Oh man, I think I can do that integral. That would be v squared over 2 plus c. Agreed? Yay or nay? Well, what is v? V is log u. So that, goodness, here's the phone again, people. I'm sorry about this. This is from Auburn, Alabama. I can't believe, but just in case it's a student, let me try it. I'm so sorry for wasting your time on that one. Something about a vehicle warranty, blah, blah, blah. I think it was just a spam call. Okay, so let's go back here. This is what this gave. V was log u. So this is log u squared over 2 plus c. But what was u? U was sine x. So this is the log of sine, I'm going to write it this way, sine squared x over 2 plus c. That's my final answer. Let's see how the book did. I hope I'm looking at the wrong problem. Yes, I am. Okay, good deal. All right, the 1/2 the log of sine, now wait a minute. Oh, I did that wrong, didn't I? Yeah, I did do it wrong. Sorry about that. Let me erase. Okay. It was log squared. Okay. Not sine squared. Okay. Log u, but u was sine x. So it's log of sine x. And the log was what was squared. That's it. That's how I should have written it. So it's 1/2 the log of sine x squared plus c. Be careful, especially on these that have so many steps in them. Okay. Now, that was example 5. Let's see how we're doing on time. We got 10 minutes. Let's see if we can get any questions on 5. Sorry about botching that up right at the end there. All these phone calls and stuff are throwing my head crazy. Okay. So let's clear the ink here. And let's try, example 6. Find this one, the integral of tangent squared of 2x dx. Now, this almost seems straightforward from what the others have been, okay? it's not quite as tricky as the others were. I say there's only one u substitution here. The innermost part of this thing is 2x. So let's let u equal to x. Then, every time you have a u, follow it with a then. Du is equal to 2 dx. So we don't have a 2 dx, we only have a dx. So let's divide both sides by 2. And we have our dx then. Now, let's write what that gives us. The integral of tangent squared u du with a 1/2 out in front, because it's du over 2 is dx. Okay. This one, if you don't know that already, flip back to your table on page 516 and look at number sorry about that, I was thinking the wrong way. I was thinking tangent squared was the derivative of secant, but it's not. Okay, secant squared is the derivative of tangent. Okay, so that would have been doable. So this one will require a little more work. Okay, now how would we approach that? Don't forget your 1/2, that's there. I'm going to rewrite this tangent squared as sine squared over cosine squared and see if that gets us anywhere. Sometimes you have to just try a few things. Oops, these are u's here, not x's. Okay, not sure that's going to be helpful. Let's try something else. Let's try this one. 1/2 Pythagorean identity here. Tangent squared is secant squared u minus 1. Pythagorean identity here. If you think about it, 1 plus sine tangent squared is secant squared, so tangent squared would be secant squared minus 1. This one now does let us do use your basic integration rule. Secant squared is the derivative of tangent, so this would be 1/2 tangent u, because the derivative of tangent u is secant squared u, and then this would be just a minus the integral of du of 1 du would be minus u. Okay, now plugging back in what u is, or u are, is 1/2, and u was 2x. Okay, this we didn't use at all. Okay, this would be tangent of 2x minus 2x, and then you have a plus c out here. Okay, because this is an indefinite integral. Now, you could rewrite part of that and have, I don't know if the book does it or not, tangent of 2x over 2 minus x, because then the 2's will cancel out there, plus c. That's another way to express it. I don't know that that's any better or worse than the others. Let's see what they did. They did 1/2 tangent 2x minus x plus c. They did take it that extra step. Good deal. Any questions? All right. There, we finished our whiteboard examples. Let's go back to the PowerPoints. If I could get my pen to show up. There it is. Okay. So let's go back to 8.1. Okay. And after example 1, we went straight to there. So we'll go from current slide right there. Now, they have here a summary, so to speak, procedures for fitting integrands to the basic integration rules. Now, one way, expand, especially if it's in the numerator. So if you have a 1 plus e to the x, go on and do your binomial expansion here. This would be 1 squared plus twice e to the x plus e to the 2x. And that's what you got there. Now, it doesn't have to be e to the x. It could have been anything there. But expand it, especially if it's in a numerator. Now, another thing, and this is a trick we did, separate the numerator into 1 over x squared plus 1 plus x over x squared plus 1. And especially if you've expanded it, then you could have separated it into 3 different integrals. And sometimes that's helpful. Another thing you can do, complete the square. Okay? Because here, that looks almost impossible to deal with, but complete the square, which would mean I don't like the way they just throw it out there as if it's intuitively obvious. Okay? They don't even show how completing the square was used here. So I'm going to try to do that for you here. And I don't have much time. We have 3 minutes. So I don't know I have time to do this. But let's complete this square. Now I'm going to do something else. I'm going to flip it around and make it x squared minus 2x. Completing that square would be x minus 1 squared. If you did that, that would give you x squared minus 2x plus 1. So, okay, I probably should have this. Let's add 1 and subtract 1. That gives you a perfect square, trinomial. That's this, and then you have a minus 1. Okay, now what we had was exactly the opposite of this. They had 2x minus x squared. I had x squared minus 1. So therefore, exactly the opposite of this would be 1 minus x minus 1 squared, and that's exactly what they've got in here. So that's how they completed the square. Just to show going from this step to that step and saying that was by completing the square. Whoa, time out, how did you do that? That's how they did it. Okay, we have 1 minute left. Let's see if this. Divide any improper rational functions. We did that earlier, and we did one very similar to this. Anytime the numerator has a degree equal to or higher than the degree of the denominator, always divide first. Okay? Now, this was the next trick that we had. Here we had something, the derivative of the denominator, if you let that be your u, was 2x plus 2. Well, here you had the 2x, but not the plus 2, so they added 2 here, but also subtracted 2. Then you go up here and separate the fractions. Separate this one, that you can do with a u substitution, and this one, which you would turn around and do basically a inverse trig function with. Use trigonometric identities. Cotangent squared is cosecant squared minus 1. Or like we did, tangent squared was secant squared minus 1. Whatever your trig identities, if something makes it better, use it. We tried cotangent squared was cosine squared over sine squared. That didn't help us any. So try something else. And then multiply and divide by Pythagorean conjugate, or any conjugate. It doesn't have to be Pythagorean. 1 over 1 plus x squared, its conjugate is 1 minus x squared. If you multiply by 1 minus x squared, 1 minus sine squared over 1 minus sine squared, you're going to get 1. So you can multiply that anytime you want to. This gives you a cosine squared down here, 1 minus sine squared. Then you can split those into 2 pieces, just like we did up there. And believe it or not, that will work. This will be a tangent squared here, or tangent here. Antiderivative of secant squared is tangent. This will be, let u equal cosine x, du is equal to minus sine x, and then you have dx over, or du over u squared, which is doable, quite doable. Okay, so those are your rules there. Now, that's the end of the section. Let me give you homework exercises here. Do number 3 is at calcchat.com. Any of the odds 5 through 13, they're all at CalcChat. 7's at CalcView. Any of the odds 15 to 45, they're all at CalcChat. 17's at CalcView. Do number 47 is at CalcChat, should be. 49 should be at CalcChat. Any of the odds 51 to 55 should be at CalcChat. 57 to 71 should be at CalcChat. 59 should be at CalcView. 73 or 75 should be at CalcChat. 77 or 79 should be at CalcChat. 81 should be at CalcChat. 83 through 85 should be at CalcChat, or 85 should be at CalcChat. 87 should be at CalcChat. 89 should be at CalcChat. Any of the odds 91 through 95 should be at CalcChat. 97 should be at CalcChat. 99 should be at CalcChat. And then any of the either 101 or 103 should be at CalcChat. So we'll begin next time with an actual new technique for integrating things that we can't integrate otherwise. And it'll be integration by parts. Any questions? Okay, sorry we ran a little bit over, but there'll be no extra charge today. I did a lot of talking about my stuff, so sorry about that. Any questions before I shut it down for today? I'm going to stop the sharing for one. Sick and tired of sharing. Okay. Any questions before we leave? Good deal, folks. I'll try to get out there on Blackboard when I can, but today and this week are going to be absolutely crazy. So I may get behind on things. Sorry about that. I'll get them done as soon as I can. Good deal. Take care. Be safe. We'll see you on Wednesday. Knock on wood. Okay. See you then. Bye-bye.